In today's lesson, Tudatarisa series expansion, we are continuing with our topic sequences and series. So when we look at series expansion is widely known as the binomial theorem. Saka, instead of saying series expansion, we can rather call it the binomial theorem. Saka, what I want to bring to your attention panapa, tese tinoziva kuti kana tichiti bi, we are actually referring to two. And my quick examples panapa, it's bicycle, bicep, bisexual, bilateral, etc. Saka bicycle, bi inoi iri kurepresenta mavhiri 2. Bicep, this is a muscle inenge ine largely speaking 2 parts. Bisexual iri kurepresenta those who have ndingati fluidity in their sexuality. Bilateral usually applies to business dealings, kana kuti dealings between states. Kana chiti there's a bilateral agreement between South Africa and Zimbabwe. Tiri kuti South Africa and Zimbabwe, they are in some sort of a deal. So this is the binomial theorem, and it's very important. What is the binomial theorem used for? Saka, we should know kuti the binomial theorem is used for expansion. And an example can be as simple as a plus b to the power n. Saka muchaona manje tichakushandisa that simple statement a plus b to the power n. Saka taona kuti series expansion can be called the binomial theorem, and we also know that it is a predetermined pattern used to expand the relationship connecting the sum or difference of two terms. Saka, it is used to expand the relationship connecting the sum or difference of two terms. So it's important to take note that we are dealing with two terms. For example, a plus b. But those two terms, they are connected arithmetically by either arithmetic operators plus or minus. Saka patiri kuti used to expand the relationship connecting the sum or difference of two terms, we know that per sum tungotaura kuti those two terms are connected by plus, and by difference kuti those two terms are connected by a negative. That is what we are talking about. Now after that realization, for positive whole number values of n, the general formula states that. Saka general formula yatuda kuisa, and sandokuna kuti the formula below. So it's a general formula, only works for positive whole number values for n. Panapa turungoti positive whole number powers, because power kana kuti n is a power or an exponent. Mapaona like that. So let us put down this general formula. Saka ndichainyora ndichishandisa two variants. The first variant if you are using a calculator. The second variant inoshanda if you are writing it on paper. Saka panapa ndinogona kuti with a calculator andika tinoti chi tiri kuti if it's a plus b dati mutererese to the power n like that. A plus b to the power n. A plus b to the power n iri equal to tinoti n choose. Saka n uyandi choose 0 like that. Toatatora a unoyu. A anenge r to the power n minus 0 irapo. Then b anenge r to the power 0. Saka as we continue to write, you are beginning, you are going to see a pattern forming. But because of kukura kwakaita this, maybe it's wise kana ndikabvisa this part and I move the formula kuside kunoku so that we can see it nekureba kwayo like that. So tikuti a plus b to the n and is equal to n choose 0, a to the power n minus 0, b to the power 0 toatati plus and panapa takuchitichi n choose 1. So atati n choose 1, a ya to the power chi n minus 1, b ya to the power chi 1 like that. Toatati plus n choose 2, a ya to the chi n minus 2, b e to the power 2 plus and so forth. So this is the formula you're expected to know. Saka there is functionality iripa calculator inenge ichitibatsira kuchooser. So if you are not familiar with this, you can communicate in the comments and I can show you how. But for now, let me just show you roughly kuti ndirikurevei. Saka you have to understand kuti zvatoda kutaura panapa zvinosiyana nefunctionality yecalculator. Macalculators anosiyana. This is just an example of a scientific calculator yandoda kukuratidzai. Saka mukatarisa pane kabutton kanaka panapa meno kana mukakwanisa kuzviona apo pakanyorwa kuti NCR. Zvinoreva kuti N choose R like that. Mathematically zvinonyorwa so kuti N R uvongodai so kuti N choose R ndo manyorerwa zvinoitwa. But chandinoda kukuchenjedza yapo ndechekuti mukatarisa muchaona kuti muite invoke this mukwanise kushandisa n choose r munobaya yo number. Let us say muroda kuti 9 choose 2 like that. Sa munotanga mabaya chi 9, then moya panapa mobaya shift. Mabaya shift moya mobaya this button dopa munge maita invoke n choose r, then mozobaya chi 2. Again izvi zvinosiyana nefunctionality yecalculator minayo. But what I'm just trying to communicate is my calculators ese even are very simple. Machinji acho anenge aine n choose r. Then panapa npr zvoreva kuti n permutation r, but we are not talking about that. Saka izvi zviri borrowed from a topic in statistics inonzi combinatorics, something along those lines, where we are discussing combinations and permutations, but we are not learning about that as yet, cannot as now. So this is what we wanted to learn betunana. Ndakuratidzai on your calculator. If you still have queries and questions panapa, you can just communicate via comments or my numbers and I can help you directly. But looking at this should not intimidate you. Maybe to make it lighter, gatiti a plus b to the power n. Like that, a plus b to the power n. Tovatati, this is equal to, instead of kunyorot nc0, which is n choose 0, tichati n choose 0. Inonyoro yakadai so. Then a inenge iri to the power n minus 0 times mukunosa dot b iri to the power 0 plus toenda pa n choose 1. A yava to the power n minus 1, b iri to the power 1, toenda pa n choose 2. A to the power n minus 2 b iri squared toenda pa n choose 3. A to the n minus 3 b iri to the 3 like that. Saka please just consider tarisai ma formulas aya just for a little while. You begin to make sense of them because they are not by design complicated. Saka ndo zvakaita izvi. But tati izvi zvinoshanda kana tichitaura pamusoro pechi expansion. So let us just do something very simple tozo continue. Saka mangwana I'm going to teach you the Pascal's triangle before we move on to the other part or section of sequences and series. So be ready for that. Okay, let us say kuti truda kudila na something simple. What can we say? 2 plus x squared. Saka 2 plus x squared, traditionally, that's our method 1. Tichangoti 2 plus x, we want to expand this. 2 plus x. 2 times 2 then inozova 2. Correct, each term in this bracket should multiply this bracket. Saka 2 multiplying 2 plus x multiplying 2 plus x. This is 2 times 24 plus 2 times x into 2x plus x times 2 into 2x plus x times x into x squared. So this is equal to 4 plus 4x plus x squared ta expanda. How about tishandise binomial theorem? Saka zvatinoita panapa manje ndezvekuti isusu tiri kuziva something. Okay, chii chatiri kuziva? Ngatidai so. Tinonyora pasi the general formula. A plus b to the power n is equal to, panapa nchangonyorangu first 2 terms. Akada kuwedzerwa nchawedzera as becomes necessary. Saka panapa ngerichi n choose 0 ndo patotanga napo. A to the chi n minus 0 times b to the 0 plus n choose 1. A to the n minus 1 times b to the 1 plus and so forth. Then panapa manje tikatarisa 2 plus x squared tunaona kuti a are equal to 2. We just take it as it appears. B are equal to x and n are equal to 2. Tasfamsa say panapa tangoya tikaita juxtapose panapa kuti a plus b to the n. Saka 2 ndiye a, then b ndi x and 2. As simple as that. Saka tadai so much. What we are going to do is we are going to rewrite this but tichi substitute. Kureva kuti panapa takutichi 2 plus x squared iri equal to n d2. Saka tukuti 2 choose 0 like this. Tova tati a ndi and 2. Saka it's 2 to the power n d2. 2 minus 0 multiplying. Then b ndi and x to the power 0 like this. So because formula yangu ndikufila kuti chatirebereka ndidonze uye kunoku. So kana tichizviita especially at this stage zoita senge we are wasting time. Taregere ngoita the simpler thing. But things are going to get a little complicated and the binomial theorem is going to be your best fit. Saka please learn it. Hapana chichodzidzirwa mahara. Saka tadai soto tati plus takutichi 2 choose 1 anditi yakuvachi 2 to the power 2 minus 1 multiplying x to the 1 torati plus 2 choose 2 yavachi 2 to the power 2 minus 2 times chi x squared. Ndo patinogumira panapa. And let me explain. I'm going to open my calculator. I hope you are also opening your calculator there. Then in my calculator ndoda kunyora kuti let us say tangatazoendera mberi chiti 2 choose 3. Sandakati 2 ndobaya 2 pa calculator yangu, it's actually a Casio. Ndabaya 2 ndo ndabaya shift ndobaya pattern rina ncr pamusoro saka yava 2c then 3 it's actually 0. Saka chinotiudza kuti takuguma kumecha kunenge kwaita panapa kuti yava 2 choose 2 because iyo 2 choose 2 yacho 2 choose 2 it's actually 1. Manzwisisa? So tinobva tainyora yakadai so ndoda kuti muone kuti ichabuda iri 4 plus 4x plus x squared. Okay, saka let me keep this part panapa. So what are we going to do apa? Let us solve it. Sa ndoda kutanga ndati 2 choose 0 ndikuwana 1 saka apa inenge iri 1 times then apa i 2 to the power 2 minus 0 which is simply 2 to the power 2 saka it's times 4 times x to the power 0 ndi 1 saka this is the first term yatinayo plus. Okay, let's go to the second. 2 choose 1 tinowana 2 saka apa it's 2 times panapa inenge iri 2 to the power 2 minus 1 which is simply 2 to the power 1 which gives us 2 and x to the power 1 x like this plus tobva tati what is 2 choose 2 we know kuti ndi 1 saka apa it's 1 multiplying 2 to the power 0 ndi 1 multiplying x squared. Solve this. 1 times 4 times 1 ndi 4 plus 2 times 2 ndi 4 times x 4x plus 1 times 1 times x squared ndi x squared like this. Saka as you can see answer yedu yabuda iri the same. Kutora the binomial theorem kwaita senge tatenderera but zvichava necessary as you become more advanced in your mathematics. So this is what we have learned. Let us take on a second example. Second example yatoda kutora is a justification of why we have to use the binomial theorem. Nekuti question yedu yakadai so iri kuti 2 minus x to the power 6. Try to solve this through traditional expansion. You take hours and you probably make a lot of mistakes. Saka to just make life simpler for you, you just have to apply this. Munenge makungoya panapa mova mati a plus b to the n. That is a wedu ndi 2 musakanganwa kuti b anenge asiri x but minus x then c wedu ndi n wedu ndi 6. Takuda kuchinyora manje saka 2 minus maybe to make life simpler a plus b to the n inenge iri totangana n choose 0 a to the n minus 0 multiplying b to the 0 plus n choose 1 kungetwa kuti musurangaridze a to the n minus 1 multiplying b to the 1 plus n choose 2 a to the n minus 2 multiplying b squared kureva kuti 2 minus x to the 6 inenge iri equal to 6 choose 0. So iyi inenge yakatirebei. Question yedu iri kuti for example the first 3 terms of the expansion of 2 minus x to the 6 are given as follows. So question yedu iri kuda the first 3 terms. So be careful to always read your question completely. Saka question yedu zvairi kuda the first 3 terms. Zvinongorova kuti tichati 6 choose 0 handiti tobva tati 2 to the power 6 minus 0 multiplying b multiplying minus x to the power 0 toti plus yava 6 choose 1 2 to the 6 minus 1 multiplying minus x to the 1 plus 6 choose 2 2 to the 6 minus 2 multiplying minus x squared. So first 3 terms, this will be term number 1 inoi ichigumira apa term 1 iri term 2 iri kugumira panapa then iyi term 3 kureva kuti zviri kuseparatewa nemaplus aya. Please don't confuse that. And futi muri kuona kuti the third term inenge ina 6 choose 2. Be careful also of that. So taona kudai so much, let us solve this. Tinobva taenda kucalculator kwedu, then tiri kucalculator kwedu toda kuziva kuti 6 choose 0 ndeani. Tazvibaya mucalculator tinoona kuti ndi 1, saka it's 1 times, then panapa inenge iri 2 to the power 6, then minus x to the 0, it's going to be any number raised to the power 0 and 1. So that's times 1 and like this plus. Panapa let us see kuti 6 choose 1 inotipa chi? Inotipa 6. So this is plus. Apa tiri kuti 6 times 2 to the 5, then times minus x, since it minus x to the 1. And then plus, what about 6 choose 2 inotipa chi? 6 choose 2 inotipa 15. So this is 15 times 2 to the 4 times, then minus x squared. It's simply x squared. Because tinoziva kuti a positive, no, tinoziva kuti an even power inocancela a negative sign. So kuisolva ish, panapa tiri kusara tina 2 to the 6, which we can easily compute panapa. Tinoona ndi 64. Saka from this bracket we get 64 plus, what about from that bracket? So there's no need for a plus since tichiona kuti eventually chava a negative. And 2 to the 5, kana 2 to the power 5 ndi 32. 32 times 32 yatawana times 6 yova 192. So this is minus 192x. Then panapa tichati 2 to the 4, the 16, 16 times 15, tunaona 240. So this is plus 240x squared. These are the first 3 terms as asked and tasked by our question. So this is the answer we are getting patring nenge tichita binomial expansion.